Okay, in this video, I'm going to go over the practice for the 2.6 quiz. So this is the first practice. Then there's an extra practice I'll probably do a video for as well. So in this practice, on the first page, you're given a function. So here's your function. And you have to identify the parent and then identify all the transformations. Okay, so I said in class that the best way to identify the parent is to take away all the numbers. So that means ignore this, ignore this. What are you left with? You're left with f of x equals x squared. So that's the parent function. Now, why don't we do this in the order we're supposed to do it? So deal with the parentheses first, because PEMDAS tells us that's what we should do. So this says x minus 6. So I know that I'm moving x horizontally to the right by 6, and then I'm going to do a vertical shift up by 11. Okay, and you can just use that notation if you like. Okay, moving on to the next one. If we ignore all the numbers and the negative signs, we get a parent function of f of x equals absolute value of x. Okay, so now what's happening? I'm going to start inside, and I'm going to say where we have a reflection or flip. Reflection. It's in next to the x, so it's over the y-axis. So that could be a horizontal reflection. Okay, so that's one thing we have. Then we have a vertical stretch by a factor of 4. Then we have a vertical reflection over x, and we're going to shift the whole graph up 7. Okay, those are all the changes. Okay, so then we're going to continue and working on the inside. Well, first off, working to recognize what this is. The parent function that we're changing or transforming is radical x. So looking inside, the first thing I'm going to do is I'm going to do a reflection or a flip or a fold over the y-axis because I have a negative in next to the x. And then I'm going to do a shrink. You can also call it a compression by a factor of 1/2. So there's 2 changes so far. What else do we have? We had a reflection over x-axis. That's from the negative outside. And we're going to go up 3. So 4 changes. Okay, next one. F of x equals the cubed root of x is my parent function. So what's happening? So inside, we're going to move right 3. Then we're going to do a vertical stretch by a factor of 6. And lastly, we're going to move the whole curve up 4. Okay, next one. Looking at that, I see that I have the original function being transformed is radical x. And I have it looks like a shrink, but it's actually a horizontal stretch by a factor of not 1/4, but you actually take the reciprocal. So it's of 4. Now, we didn't tell you that part of it, so all you have to really say is that you have a horizontal stretch. Okay, then the next thing we have is a vertical stretch by a factor of 3. And then after that, we take the whole function and move it up 5. Okay, one more. This is also f of x equals radical x. And inside, I'm going to have a horizontal shrink by a factor of, so 1 over 4, which is 1/4, because there's always 1 over the number. Okay, then what else do I have? I have a vertical, since it's a number less than 1, I have a vertical, not stretch, but shrink by a factor of 2/5. And then lastly, it's going to say take your whole function and go up 3. All right, so that's the first kinds of problems we're going to be responsible for. Now I'm going to give you the parent, give you the transformations, and you give me the transformed equation. Okay, so that's our next game plan. So what we have is this. I'm going to look here, and I'm going to figure out what this is going to be. Well, I know it's going to be x squared, so I am thinking it's going to be y equals 4 times x minus 2 squared plus 3. So why is that? Let's go through it. So if I say shift right by 2, that's this right here. If I then say shift up by 3, that's this right here. And if I say, lastly, vertical stretch by a factor of 4, that is this right here. So that's how I got my answer. Okay, so the next one's going to be y equals negative 1/2 x plus 2 squared. Let's figure out how come that's what it is. So if I want to shift left by 2, that will do it. Looks like it's going right, but we know it's going left. Then next thing, I have a vertical shrink by a factor of 1/2. So that's going to be this, not the sign, just the fraction. Then the last one is going to be a vertical reflection, and the vertical reflection is just the sign. Okay? So that negative does not have anything to do with the vertical shrink. Okay? It has everything to do with the vertical reflection. All right, next one. If I say that this is going to be parent function is y equals radical x. So I believe I'm going to do this. Y equals this, and then x plus 3. And then outside away from the radical, I'm going to say minus 4. So let's figure out where these are all coming from. So shift left by 3. Here's left by 3. Then shift down by 4. That's down by 4. And then the last piece, a vertical reflection, that happens with just the negative. Okay, so we're matching things up here. Okay, next one should be y equals x cubed is the parent function. So I believe I got y equals negative x cubed minus 1. Okay, so what's happening here? Look at what the steps seem to be. Vertical reflection, that has to do with this negative sign. Horizontal reflection, that has to do with this negative sign. And then lastly, shift down by 1, that has to do with the ending of the equation. Okay, keep on going here. Okay, so this one's a cube root. So I have y equals 1/3, and then here comes the cubed root of x minus 7 and then it's going to be minus 7 outside. So let's see if we can figure out how I got what I got. Starting off with the vertical shrink by a factor of 1/3, that's this. Horizontal shift right 7, that's this. And lastly, vertical shift down 7. Oh, let me not do it in yellow. Let me do it in green. There it is. Okay, I've got one more. This is going to be y equals 2.5 and then a negative x squared minus 3.3. Okay. Horizontal reflect. Oops, sorry. Here. Okay, horizontal reflection. Horizontal reflection. Be inside next to the x. And then a vertical stretch by a factor of 2.5 is right here. And then a vertical shift down 3. Here's the vertical shift right here. Okay, so that's all set. Okay, for this one, what I do first is I redraw the parent function. So the easiest way to do this by far is to first trace over this. Well, I'm going to do it in regular ink. I'll do it in red. Okay, so I'm going to trace. Okay, so now I'm going to circle this and say copy. I'm going to put it here, say paste, and then I'm going to move it so that it's exactly where I want it to be. And then over here, do the same thing and move it so that it's where you want it to be. And then do the same thing here. Okay, and I'm going to move it right where I want it to be. Does that look good? Oops, let's go a little bit below. Go with this. Okay, so let me do that again. So I'm going to turn this off for a second. I'm going to clean these up, and then we'll start talking about it. Okay, so I've got my parent functions. I'm going to do the other function in black. Okay, so what I'm going to do, I'm going to first figure out what's going on here. So I'm going to go left 2 and down 3. So take this point right here, go left 2, 1, 2, and then down 3, 1, 2, 3, and change your shape. It's right there. Okay, left 2, 1, 2, and then down 3, 1, 2, 3. Change your shape. It's right there. Okay, from this guy, I'm going to go left 2, down 3, 1, 2, 3. There we go. We're going to put that right here. And then one more step. Take this, and I'm going to go left 2, 1, 2, down 3, 1, 2, 3, and here we are. So then let's just play connect the dots. Okay, and then that's done. All right, so let's do the next one. So the next one is just going to be a vertical stretch by 2. So that means take this point right here. Your y value is -1. Multiply that by 2, and that puts us right here. Next point, your y value is a 3. Multiplied by 2 gives you a 6. That's going right here. Here, your y value is 1 multiplied by 2, and that's going to put me right here. Here, your y value is 3 multiplied by 2, and you're going to get a 6 up here. And then play connect the dots, and that looks very much like a stretch. All right? Okay, last one of these. This just says that I'm going to reflect over the y-axis. Okay, so if I have this point right here, and I go on the other side of the y-axis, it's going to be right here. If I have this point and I go across the y-axis, it will be here. If I have this point right here and go across the y-axis, it's going to be here. And if I have this point that is 1, 2, 3, I'm going to go 1, 2, 3, and I'm right here. So when you connect those dots, or those triangles, that's what you get. So that's what happens if you flip it over the y-axis. Okay, so now we're going to do our graphing. So I'm going to have you graph your parent function by first identifying it. Okay, there's my parent function. So here I have this, and I have -2, 1, 2, 3, 4. +2, 1, 2, 3, 4. There we have it. Here's my parent function. Okay, so I'm going to list my changes. So I'm going to do a vertical stretch by a factor of 2. And then once I do that, I'm going to say down 4. Okay, so change in color. If my point is right here, and I multiply that by 2, that's going to put me at +8. 1, 2, 3, 4. So that's right there. Then if I subtract 4, I come right back here. So this is my first point. Go to the second point. The y value here is +1 times 2 is +2. So I'm there for a second. Then go down 4. 1, 2, 3, 4. And I'm going to put my little triangle there. Okay, other point. My y is at 0. 2 times 0 is 0. And then go down 4. 1, 2, 3, 4. Good. Now I'm going to get some symmetry going here, but let's still check our answers. So I'm looking and I'm saying at this point right here, multiply by 2. And that's going to bring me here temporarily, and then go down 4. 1, 2, 3, 4. Exactly where I wanted it to be. And then if I was just going to use symmetry, I'd say that this is my point, and I can go back and verify that whenever I want to. Okay, there we have it. Okay, here's another one. All right, for this one, the first thing I'm going to do is plot my absolute value function, and I'm keeping my numbers pretty close. So here's, remember you need 5 good points. There are 5 good points right there. There we go. That's better. Okay. All right. So now let's work with these points. I'm going to first list my parent function, which is this, absolute value of x. Then let's figure out what's happening to it. So I'm going to the left, 1. I'm going to do a vertical stretch by a factor of 2. Okay, so I've got 2 things so far. Then that negative tells me to reflect over the x-axis. And lastly, I'm going to say up 5. Okay, so we're going to take this. Let's change our color. Maybe we'll do a light blue. And I'm going to take this point. I'm going to go to the left 1. Okay, I'm going to stretch that by 2. If I multiply, this is 2 by 2, I get 4, so I'm up here. Then I'm going to reflect that over the x-axis. If that's up 4, I'm going to be down 4. 2, 3, 4. I'm here temporarily, but then it's going to be up 5, which puts me right here. Okay, go to our next point, and this says go left 1. That puts me right here. Then I'm going to look at that. Is that 1? If I double that, I'm at 2. Then I'm going to go over the x-axis, and that puts me right here. and then I'm going to go up 5. 1, 2, 3, 4, and 5. So it looks like I'm going up there. Okay, so look at your work, see what you think. Then I'm going to go to this one. If I look at that and I try to go left 1, I'm right here. And then I want to do a vertical stretch by a factor of 2. 2 times 0 is still 0. Reflected over the x-axis also does not change. And then go up 5. 1, 2, 3, 4, 5. That's where it's supposed to be. Okay, so I have a couple more to do, a couple more points. I'm going to grab this little point, and I'm going to say, okay, given that point, what should I be doing? I'm going to go to the left 1. That puts me right here. I'm going to multiply that 1 by 2. That puts me right here. I'm going to flip that over. That puts it right here. And then I've got to go up 5. 1, 2, 3, 4. Right here is 5. Okay, we've got one more little point right here. So that point, I go over 1. I'm right there. Vertical stretch by a factor of 2 means that if I'm on positive 2 now, and I say 2 times 2, that's going to be 4. So 2, 3, 4. So now I'm here, and I'm going to reflect it over the x-axis. So if I'm up 2, I'm going to be down 2. 1, 2. So I am up 2. So I'm down 2. So where's that next part going to be? I believe I'm going to be right here. Okay, so here is my transform function. Make sure that you can do it. And I've kind of done that incorrectly. It's an absolute value. I do not want a smooth curve. I want straight lines. Okay, that's my transform function. We've got a couple of more, and then we're going to do some more work over here. I'm going to do 6. Okay, for 6, we're going to identify the parent function equals x squared. Go ahead and plot the parent function. So negative 2, 1, 2, 3, 4. Okay, so this is going to be a smooth curve. It's a parabola. There we go. Okay, so what's going on with this parent function? Looks like I'm going to go to the left 4. Then I'm going to do a vertical stretch by a factor of 3. So this is 1 thing, 2 things, 3 things. I'm going to go down 7. Okay. Find a nice color to contrast. And we start at the furthest point to the left. I'm going to move that point 4 to the left. 1, 2, 3, 4. There I am temporarily. Vertical stretch by a factor of 3. So if this is on 1, 2, 3, 4, 4 times 3 is 12. So this is 4, 5, 6, 7, 8, 9, 10. Let's just make sure I'm up here. Make believe I'm up here at 12. Okay, because I'm going to go down 7. So now I'll go down 1, 2, 3, 4, 5, 6, and 7. So even though I had gone up so far, I came back down. So everything was good. And I'm back on my little grid. Okay, next one. Let's figure out where this point's going to go. And I'm going to go left 4. 1, 2, 3, 4. Just making little tiny dots. And then I'm going to vertically stretch that by 3. So it was on a y of 1. It's going to be a y of 3. So I'm going to be up here now temporarily. Now from this vantage point, go down 7. 1, 2, 3, 4, 5, 6, 7. That's your next point. Okay, we're going to circle this one. Move it left 4. 1, 2, 3, 4. You're at 0. 0 times 3 is still 0. Then go down 7. 1, 2, 3, 4, 5, 6, 7. Okay, so you can see you have the pattern coming of a parabola. Okay, let's go up. And I'm going to figure out by symmetry. Can we figure out by symmetry? that should be that point, and by symmetry, this should be that point. Okay, so if you test it out, you're going to see that the symmetry is going to work just fine. All right, that's my transformed graph. Look at this one. Get yourself a parent function, which is going to be g of x equals radical x. So square root of 0 is 0. Square root of 1 is 1. Square root of 1, 2, 3, 4 is 2. And we need 4 points. Let's do one more. Square root of 9. This is 4. 5, 6, 7, 8, 9. Square root of 9 is going to be 3. So we have plenty of points. And this is going to go on. Okay, good. So that's my original graph of the parent function. Let's now change our colors. And what do we have to do? We have to vertically reflect over x. And then once we do that, we're going to go up 4. Okay, so if you take this point and vertically reflects over x, you're still right there. And then I need to go up 4. 1, 2, 3, 4. This next point, if I vertically reflect it, I'm here. And then go up 4. 1, 2, 3, 4. Okay, take this point, and I'm going to vertically reflect over x. So I'm going to be 2 above, so I'm going to be 2 below. And go up 4. 1, 2, 3, 4. I'm right on top right here. Okay, and then go to the next point, which is all the way over here. If I vertically reflect that, I'm going to be 1, 2, 3 up, 1, 2, 3 down, and then go up 4. 1, 2, 3, right there is 4. Okay, so we're going to go like this. And this goes forever and ever that way. Just like that went forever and ever that way. Okay, so those are those types. Then what we're going to do here, each of these subsequent problems are based on the previous one. So let's talk about how we're building. Okay, so initially the parent function is f of x equals x squared. The transformation to that parent function is I'm going to go to the right 1 and up 1. Okay, that's really easy. So let's draw the parent function. Okay, and then I'm here. 2, 1, 2, 1, 2, 3, 4. Okay, so here's my basic parabola. And now we're going to do the transformation. And I'm only going to do a couple of quick things. We're going to go red. Okay, so from this position, I'm going to go to the right 1. So right 1, up 1. 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 All right, and there's your transformed function. Okie dokie. Okay, so now let's get the domain and the range of the red guy. So all parabolas have all real numbers as the domain. Your range is going to start at the lowest point, which is 1, and you can equal it, and it's going to go all the way to infinity, and we're done. Okay, how do these compare? Take the exact same function, and now you're going to stretch it by 2. So that means that I can say that I'm going to do this, right? So let me just say copy. So I'm doing that exact thing, paste. And then what am I going to do next? So I'm going to change to brown. Okay, so the other thing, the new thing, is that I'm going to do a vertical, oops, let me just do that better. Vertical stretch by a factor of 2. Okay, so take your parent function, here, here, here. Okay, and sketch this little puppy out. Here's my little sketch. Okay, so that's done. Okay, so now let's build the new one. So what I could do is I could pull the other one down, couldn't I? And then do changes to that. But let's not do that. That's going to complicate things. I'm going to make this one purple. So I'm going to take this point and do exactly what I just did. Go to the right one. But now, instead of going right into the up one, I'm going to do the vertical stretch because I'm trying to follow the rules of PEMDAS. So if this is 4, I'm going to go up to 8. So this is 4, 5, 6, 7, 8, and then go one more. So I'm up there. Clearly a stretch. So for this one, I'm going to go right 1, takes me there, and then 2 times that puts me here, and then I'm going to go up just to one more. So I'm going to go up 1, and I'm here. So let's just verify that what I'm doing is good. Yep, I'm good. Okay, here's your origin. So I'm going to go to the right 1, puts me here. If I say 2 times that, I'm still there. And then I'm going to go up 1, which puts me right here. Okay, now from that point, I'm going to go right. I'm going to go, right 1. So I'm here. Then I'm going to get stretched by a factor of 2. So that's going to put me here. And then I'm going to go up 1. And that's going to put me here. So I see my symmetry coming. Okay, one last point. I'm going to take this point. And I'm going to go right 1. Then I'm going to say, okay, where am I? I'm at 4. So I'm going to go up to 8. So 4, 5, 6, 7, 8. And then I've got to go up 1, which puts me up here on 9. So now you can use a smooth curve to connect these points. And you can see how my function has changed by those transformations. Okay, domain and range. It's another parabola. That's still my domain. My range is going to start again at 1 and go to infinity. Done. Okay, next one. Look what's going to happen. I'm just going to take that curve I just plotted and I'm going to flip it over the x-axis. So I can grab this. Okay, I'm going to say copy. And I'm going to put that right here. Okay, because these are the things I'm doing. And then I'm going to do one more thing. What's the other thing? So it looks like I'm going to go and reflect the x-axis. And that's my new thing I'm doing. Okay, my parent was still f of x equals 2. This should be equals x squared. Get that parent function. 1, 2, 3, 4. Very good. Okay, so here's my parent function. And what shall I say? Well, do we want to try to play around with this? No, I think not, because it's too many points. Okay, so we're just going to do this. So let me change into a nice bright color. So if I'm at this point, what will happen? I'm going to go to the right 1. Then I'm going to do a vertical stretch by a factor of 2. But before I do that, I think I'm going to flip it over. Okay, if I'm here, if I flip it over, I'm at -4. 1, 2, 3, 4. Then multiply that by 2, and that's going to be -8. 4, 5, 6, 7, 8. So I'm there. And then what do I want to do next? I want to go up 1. Okay, so I'm up 1, and that means I'm right here. All right, so we're going to keep going. That is good. Let's do the next point. The next point, I'm going to go to the right 1. That puts me here. Reflect over the x, multiply by 2. That puts me here. And go up 1, and that puts me here. All right, third point, which was the vertex. So I'm going to go right 1, go over the x-axis, that stays there, multiply by 2, still stays there. And then I'm going to go up by 1, and that puts me right about here. So, oh, I'm sorry, I have to go over 1. That puts me right around there. Okay, is that right? Let's see, is that right? Let me look at that one more time. Let me go back for a sec. Okay, so I'm looking at this point right here, and I'm going to say I'm going to go right 1. That puts me right here. Then I'm going to flip over the x-axis. That puts me here. Multiply by 2. That puts me there. And then go up 1. And that's going to put me over here. Let me work on some symmetry. So let me go back, and I don't know why I'm having trouble with this. So let me just go back for a second, and let me start this again. Let me just make sure all my points are good. Yep, they're all good. Okay, one more time. Okay, so one thing I'm going to do, I'm going to number these. I'm going to do this first. I'm going to do this next. I'm going to do this probably third. And I'm going to do this fourth. Okay, that will help me. So from here, I'm going to go and this is 1. Okay, I'm going to go right 1. So here's my right 1. Then what comes next? I'm going to flip over the x-axis. So I'm down here at 1, 2, 3, 4. Multiply that by 2. That puts me down at -8. 4, 5, 6, 7, 8. I'm down here. And then what comes next? Up 1. So I'm there. Okay, over here, I'm going to go right 1. So that puts me here. I'm going to flip over the x-axis, multiply that by 2, and then I'm going to go up 1. That puts me here. Take my original vertex, go over 1, flip over the x-axis, times 2, and then up 1 puts me right here. Okay, from that point that's covered by that red triangle, I'm going to go over 1, flip over the x-axis, multiply by 2, and then go up 1. There's my symmetry coming. Okay, and using symmetry, my last point would be there. And here's my new curve right there. Okay, so what do I know about that curve? Domain and range. Domain is still going to be -infinity to +infinity. Range is going to be -infinity. Remember, probably a good idea to put the arrowheads all the way up to a value of 1. And that's done. Okay, so then let's look at the next one. This is the change. Okay, and when I see a change that's going to require horizontal stretches or compressions, I'm going to use a t-table because I just find it so much easier. But basically what I'm going to do, in essence, is take this red graph and stretch it horizontally. So it should become wider. So let's see if I can show you a table, because you want to maybe have this as an option in your back pocket, you know? So here's my original function. Here I have it. -2, 1, 2, 3, 4. -2, 1, 2, 3, 4. Good, there it is. Okay, now I'm going to do I'm going to list these out. So I'm going to go and write it nicely. So I'm going to go this way 1. That's my first change. I'm going to, how about if I flip over X? That could be my second change. Then I'm going to stretch vertically by 2. And then what else am I going to do? So when I had also, another thing I hadn't talked about yet is this. So that looks like it's a compression, but it's actually a stretch horizontally. And that horizontal stretch is by not 1/2, but by the flip of that, by 2. And then the last thing, I'm going to go up 1. Okay, so instead of doing it by doing all these steps, I'm going to show you the theoretical approach with a little t-table. Okay, so the first thing I'm going to do is I'm going to erase this, and I'm going to say, okay, I'm going to pick an x so that these numbers right in here work out very well. So and I want to kind of have negatives and positives. So I'm going to start with a -2. Look what happens there. If I plug a -2 in for x, -2 over 2 is a -1. Okay, -1 minus 1 is a -2. At that point, I'm squaring a -2, which is a 4. Multiply that by 2, which is an 8. Negate that, which is a -8, and add 1 to it, and that makes my y a -7. Okay, first number. Okay, think of another number that's going to help me not have a fraction inside those parentheses. How about if I use 0? Okay, I'm going to start heading up a little bit. Use 0. I'm going to erase what I have here. And if you plug a 0 in, 1/2 times 0 is still 0. 0 minus 1 is still -1. Square -1, and you're going to get +1. +1 times a -2 is a -2. Plus 1 is a -1. Okay, so that was not bad either. Okay, let's go continue this fashion. Why don't I go and try to use a 2? 2 is going to work out great because 2 over 2 is 1, and 1 minus 1 is 0. 0 squared is 0. 0 times -2 is still 0. I am left with a +1. Okay, go up 2 more. 4, because 4 will have things cancel as well. So if I put a 4 here, 4 divided by 2 is 2. 2 minus 1 is 1. 1 squared is 1. 1 squared times a -2. -2 times 1 is -2. Plus 1 is another -1. We need 5 good points. I'm going to grab a 6 because that will also eliminate any kind of fractions. If I use a 6 in here, then 2 divided by 6 is 3. And 3 minus 1 is 2. So 2 squared is 4. 4 times a -2 is a -8. Plus 1 gives me the -7 again. Okay, so now plot these. So go over -2. 1, 2. Let me change my color. So over 2, down 7. 1, 2, 3, 4, 5, 6, 7. That's 1 point. Go to 0, -1. It's another big point. 2, 1, 2, +1. My guess is that's my vertex. Go to 4, 1, 2, 3, 4. And then go to 6. That's 4, 5, 6. And 4, 5, 6. And come down here. Okay, that is my graph. So you can see, if you look at the two of them, you see how it's stretched out? That was my goal, to stretch it out. And it's stretched out by a factor of 2. So the domain is still going to be -infinity to infinity. And the range is going to be -infinity all the way up to a value of 1. And we are done with the review. So, you know, when you use this review, you want to stop it and listen to what I'm doing, and then make sure that you could do it, and then go over only the things that you need to go over. Okay, so that concludes this review.